if I took out all but one tube, if it just left one tube inside here, then this cell would be operating at 6 volts. And if I left 2 tubes inside, then this cell would be operating at 4.5 volts. So the point is, you want to try to drop that voltage down, and that's why we try to use 7 blades or somewhere in there to break the 13.5 volts down to less than 2 volts at each surface area. Now the less volts that you have at the surface, conductive surface, the more sodium hydroxide or potassium hydroxide you're going to use. If you're using anything other than sodium hydroxide, potassium hydroxide, you're probably going to want to change to one of these two. This is not hard to get. There's instructions on the website how to get this stuff sent right to your house. It's cheap, so go ahead and use that. The reason that you have to use more of this is that when you use distilled water, you only want to use distilled water because it doesn't have minerals in it. The distilled water has a really high resistance. So if you were to take 2 probes and a gallon of distilled water and put them in there, you might just read it over, but you might not even read resistance. As soon as you start to add some sodium hydroxide or potassium hydroxide, you'll start to see the resistance coming up, going down. So the idea is, by adding a couple of teaspoons to a gallon of water and filling up the system, you turn the system on, see where the amp draw is at that amount, and then that'll tell you how much you need to get to whatever amp draw you need. So you put two teaspoons in a gallon, you fill up the system, you turn it on, you got 3 amps, you're shooting for 5, add another teaspoon and a half to your gallon, put it in there, and you should be at 5 amps. And our systems run between 5 and 10. If I run more than 7 amps on my band, it's too much gas. So we recommend an amount of gas before you start to get detonation about between a half liter, sometimes less, sometimes between a quarter and a half liter on the smaller engine. But less hydrogen, it could be the quality of the gas, I'm not sure, but we find that we can't run more than 8 amps on a 4-liter engine. I can run up to 10 amps on a 4.6 engine, but any more than 10 amps and it'll start to give me worse fuel mileage. And the reason for that is the pistons moving up, and in all combustion engines, the timing is set ahead of top dead center because fuel burns slower than hydrogen. So as the pistons coming up, the spark happens here, and it takes a little while for that ignition to happen. So as the spark plug comes up, it sparks. As the piston comes up, it sparks here, and the gas doesn't combust until here. When you add hydrogen, as the piston's coming up, the spark happens, and then boom, now the piston has to force past that and then go down. So the hydrogen explodes way faster than the fuel, causing what I call a threshold effect, which is your maximum saturation of hydrogen in your fuel content, your fuel-air mixture, has been reached at the threshold point. Once you get past that threshold, you're in detonation. And detonation is the pistons hitting the expanding gas before top dead center and then going down. So what we do is we try to keep the saturation level of the hydrogen down to the point where the engine can manage it without detonation. And that's where we find half a liter to 3/4 of a liter in most cars is adequate. Now, past that, if you were to take a 12-inch and you want to put 2 liters a minute in it, if you put 2 liters of this hydrogen in your car, it's just going to ping and knock and get terrible gas mileage and who knows. But it's not going to run. But that's because you're hitting, if you've got a knock sensor, your knock sensor is going to be going crazy, your check engine light's going to be on, it'll be an open loop, it'll be all kinds of problems. The only way to get past that is to change the timing, and on most cars, unless you spend $5,000 or $10,000 on an engine manual system, then you can actually make your own fuel map and timing map and all that. You're not going to be able to do that. Now, if you've got a carbureted car with a manual distributor, that's easy enough to change the timing. And if you're going to run straight hydrogen, then you're going to run probably 20 to 30 degrees burst retarded timing. Well, anyway, so you're going to make your timing retarded, and then the engine will be happy because it's got retarded timing. So, but the idea is the hydrogen explodes and the gas burns. So you have an explosion with hydrogen, but you have a burn and expansion with gas. So the more hydrogen you put in there, the more bang you get. And in that case, you have to be past top dead center if you have too much hydrogen. So if you want to use more than a half liter to 3/4 liter on most engines, up to a liter, you'll have to just start changing the timing to get past top dead center before it sparks. Otherwise, you start to hit the detonation. Now, I think that pretty much covers it. I would show you the plasma arc, but once again, I got in trouble. So.
Oh, okay.